All right, in the last lesson, we learned the sine law and how to use the sine law in order to solve for non-right angle triangles. Now we're going to use the other one that we can apply, the cosine law, which works in different circumstances than the sine law does. So, if we consider the triangle that's on the right, ABC, where A is 36, AB is 3, and AC is 6, what happens when you try and apply the sine law? Well, the sine law would state that side length A, which I don't know, divided by sine of 36 degrees is equal to side length B, which we do know, divided by sine of angle B, which we don't know, is equal to side length C, which we do know, divided by side length angle C, which we don't know. And the problem is we don't have enough information to create an entire combination of a side length and an angle. We can't solve for what the angle B or C is here like we did in previous cases, because in order to solve the third angle in a triangle, we can use the two other triangles but only have one triangle. So it could be any other two numbers that add up to the missing 144 degrees. And because we don't have the combination of an angle and the side length opposite, we can't solve this missing side length. So now we need to come up with a new method where we can solve if we don't have the combination of an angle and the side length opposite. The way that we do that is unlike in the previous case where we created an altitude by cutting down perpendicular to one of our side lengths and splitting the triangle in half. We extend out the triangle to create the new side length, like we can see here. So we have a new point D, which creates a right angle triangle where C to D is perpendicular to A to D. Given this, we can solve what we're missing. We can find side length CD, given that this is now one big right angle triangle, and we know the acute angle, which is at A, and we know the hypotenuse, which is represented by B here. So I'm going to say that sine of 36 is my opposite, CD, over my hypotenuse of 6. So CD is going to equal 6 times sine of 36, or 3.5267 centimeters approximately. We can use the same thing to solve for what the entire length of A to D is. In this case, we're just solving for the adjacent side length of this larger right angle triangle that we've created. And we can say that cos of my angle is going to equal AD divided by my hypotenuse of 6. So AD is going to equal 6 times cos of 36 degrees, which is going to give me approximately 4.8541 centimeters. I can now solve for what the length of BD is, because BD is just AD minus AB. BD is going to be that 4.8541 minus 3, or 1.8541. And now, if I'm trying to solve for what this side length is, I know what this side length is, I know what this side length is, and it's a right angle triangle, I'm just going to use my Pythag. I can say that BC squared is equal to BD squared plus CD squared, which we've already solved. This is going to be the same as 1.8541 squared plus 3.5267 squared. BC squared is going to equal approximately 15.8753. So BC would equal the square root of that. And to the nearest tenth, like it asked for, that's going to be 4.0 centimeters. Now, much like with the sine law, there's an easier way. It's called the cosine law. The cosine law is just using the Pythag theorem and then extending out the points in order to solve it. If I said that I'm going to simplify to a squared is equal to b squared plus c squared minus 2bc cos a, then using that Pythag, I know that going from BC, which is my hypotenuse squared, it's going to equal my CD squared plus my BD squared. Now CD is my altitude, BC is my A value, and like in the previous example we did, dB is the entire length here of C, side length opposite angle C, minus the length of X here. Based on that, I'm just solving my Pythag like we previously have. I can square that out and say that it's going to be c squared minus 2cx plus x squared. The next thing I'm going to do is I'm going to group together my h squared and my x squared and leave my c's off to the side. And if I'm taking my h squared plus my x squared, you'll notice that here's h, my height, here's x, and those are all part of another right angle triangle here, where that's just solving for my b value. H squared plus x squared is going to be b. They pulled out the value of x from the information on this side. If cos A is equal to x over b, then x would be the same as b cos A, just using my basic trigonometric ratio. So we substitute that in and call that b cos A. So now I can say that a squared is equal to b squared plus c squared. All they did was they rearranged the order of the multiplication. They multiplied the b first instead of c, but it doesn't really make a difference. Minus 2bc cos a. Now, the most important part of this is whenever I'm trying to solve any side length, the side length squared is going to equal the other two side lengths squared and added together, minus 2 times the other two side lengths times cos of the angle opposite the side length that I'm solving. That's the biggest thing. It's true for all of them. A side length squared is equal to the two other side lengths squared and added together, minus 2 times the other two side lengths times cos of the angle opposite. So if I put that into practice for this example, then I'm going to say that if I'm trying to solve side length A, then a squared is going to equal the other two side lengths squared and added together, minus 2 times the other two side lengths times cos of the side length, or of the angle opposite the side length I'm solving. And from there, I know what B is, I know what C is, and I know what angle A is. I can drop that information in and say that a squared is equal to 6 squared plus 3 squared minus 2 times 6 times 3 times cos of 36 degrees. Now the key here, and this is where some people make a mistake, is remember that's solving because it's based on Pythag what the value of a squared is. It's not actually telling me the value of a. So if I said that a squared is equal to 15.8753 yada yada yada, the last thing I always have to do is square root both sides. If it tells me that it's a squared, I always have to square root both sides to actually solve that a is 4.0 centimeters. For example 3, it says find the length, the nearest tenth of a centimeter of the third side of triangle PQR if Q to P is 1.7 centimeters, Q to R is 3.1 centimeters, and PQR is 110 degrees. In this case, I'm trying to solve side length Q. So, side length Q squared is going to equal the other two sides squared and added together minus 2 times the other two sides times cos of angle Q. Q squared is going to equal 16.104 yada yada yada. And don't forget, this thing most people mess up, you still need to square root the answer in the end to solve that Q is actually rounded to the nearest tenth, 4.0 centimeters.